Alright, another type of quadratic function you're going to see is listed in intercept form. So we've had vertex form, standard form, and now the third method is intercept form. Each method has its own benefits, so the main benefit of intercept form is that you can graph this pretty easily looking at the intercepts, and the intercepts are given to you in this form here. Think about when we were transforming equations. We were using this value inside the parentheses and doing the opposite value in the direction of which way it was going to tell us how many spaces left or right we were moving. So essentially the same principle applies when it's written in this form. I can find the x-intercepts straight away from this graph by doing the opposite of what's inside the parentheses. So this is telling me that one of my x-intercepts is that x is equal to -3. So this is -3, 0. Another intercept is that x is at +1, because I'm doing the opposite of what's inside the parentheses. So another intercept is at 1, 0. So right away I've already done the first part where I've labeled the x-intercepts. To get the vertex, once you have the intercepts, what's nice is that the vertex is always halfway between the intercepts. So what you do is you take your x values on your x-axis for your x-intercepts, you just add them together. So I have -3 plus 1, and you divide it by 2, because you want to get the halfway point. So -3 plus 1 is -2, divided by 2 is -1. So that means that my axis of symmetry, which is one of the other things I have to label, is right through -1. And I'll label that as x equals -1, because that's the equation of that line for the axis of symmetry. To find the vertex, we do the same idea that we've done before. We take our axis of symmetry value, the x equals, and plug it in and solve for the f of x. So f of -1 equals -2 times -1 plus 3 times -1 minus 1. So I just plugged in -1 into my x value, and then now I can figure out where my vertex is. -1 plus 3 is 2. -1 minus 1 is -2. Multiplying that together, I get +8. Because -2 times 2 is -4, and then times -2 is +8. So my vertex is at -1, 8. So I can tell this graph is going to be going downward, and right away from the beginning I could have told you that as well, because my first value, my value in front of the parentheses, was negative. So that tells me that this is going to be a graph that goes down. To find the other values, because you want to try to get 5 at least to give you a good sense of your graph, we already know the vertex. So I'm going to put the vertex in the middle, which is -1, 8. And what's nice about this one is that I already know 2 spaces to the right and 2 spaces to the left. So 2 spaces to the left was -3, 0. And then 2 spaces to the right was 1, 0. So here, all I have to really do is plug in -2 or 0, either one, into this equation. And because of the symmetry, I'll be able to figure out where the other points are. So I'm going to go with 0, just because for me 0 is easier. So if I do f of 0, -2 times 0 plus 3 is 3, and then 0 minus 1 is -1. Multiplying that all together, I get +6. So at 0, 6, I have another point, and then because of the symmetry, I know at -2, 6, I should also have another spot. And then here, now I've got a nice quadratic graph. Remember, if you aren't seeing this symmetrical image on either side of the line of symmetry, you did something wrong. So there's a couple good places to check as you're doing your work. But this is the problem for intercept form.